Hello, welcome back to Mrs. Torres' YouTube channel. Today we are going to be solving some equations that have radicals in it. So of course a radical is like this square root symbol, right? So we're going to be talking about some square roots, some cube roots, and maybe some higher roots like fourth root. Alright, let's look at number 1 together. We are on page 1 in our new packet here. So if we look at this equation right here, we got 54 equals 6. And remember, when you have a number next to the radical, that means 6 times the square root of 14b minus 3. So we always want to isolate our variable, right? We're trying to get that by itself. But when we have radicals, what you want to do is get the radical all by itself. And then we can get rid of that radical and keep solving our equation. So we've got 6 times the radical, so we've got to divide both sides by 6. 54 divided by 6 should give us 9. So that'll leave us with 9 equals the square root of 14b minus 3. Now that we have the radical all by itself, think back to geometry maybe, when we did the Pythagorean theorem, right? And we were left with something like x squared equals 25. The opposite of squaring something was taking the square root, right? So the opposite of taking the square root is squaring something. So we need to square both sides. I'm just going to kind of go over here. So 9 squared will give us 81. The square root of 14b minus 3 squared will leave us with just 14b minus 3. And now it's an equation we all know how to solve. Add 3 to both sides. 84 equals 14b. 84 divided by 14 will give us b equals 6. So that's it. Get the radical by itself, square it, and then solve for your variable. Let's look at a cube root one. So let's look at number 6 here. I'm going to rewrite it over here so there's a little more space. So again, we want to isolate the radical, so we're going to add 8 to both sides. So we'll be left with the cube root of 7n minus 7 equals negative 1 plus 8 leaves us with 7. Lots of 7s here. Now, we're not going to square this because the opposite of taking the cube root is not squaring, right? The opposite of the cube root is cubing. So we'll raise both sides to the third power. On the left side, the cube root and cube cancel out. We're left with 7n minus 7 equals 7 cubed will give us 343. And then we just solve like normal. So add 7 to both sides and divide by 7. N equals 50. So really it's just solving equations. It just kind of throws in a new skill here, knowing that the opposite of the cube root is cubing it. Opposite of taking the square root is squaring something. That's our inverse operation there. Alright, let's look at one of these higher root ones. So let's look down at the bottom here. We've got 7 equals the fourth root of 16k plus 1. Well, our radical is already isolated here, so that's nice. So we just need to get rid of this fourth root. So we're going to raise both sides to the fourth power. Because taking the fourth root and making something to the fourth power, those cancel out. So we have 7 to the fourth, which gives us 2,401 equals 16k plus 1. And now we just solve for k. So subtract 1, divide by 6, you'll get k equals 400. One thing that I forgot in these top ones, when you're solving equations that have a radical in it, sometimes we will have extraneous solutions. So that means solutions that when you solve it, you get that answer, but when you check it, it doesn't work. So get in the habit of when you have a radical, you want to check to make sure your answer actually works. So b equals 6 here. So let's plug 6 into our original equation. So 54 equals 6 times the square root of 14 times 6 minus 3. If you want, you can just type this entire thing in your calculator. So let's see, 6 times the square root of 14 times 6 minus 3. And if we get 54, that means our answer is correct. If we don't get 54, that means it's an extraneous solution. But we do get 54, so therefore b equals 6. So when you have radicals in your equations, you want to get in the habit of checking for extraneous solutions. And we'll see more extraneous solutions actually in our next section, 7-8. All right, see you later.